Hello all, I am Professor Snehal Shinde from JSPM Nani Technical Campus. Today we are going to study the subject computer graphics. And from this subject we are going to study some of the topics from 5th unit, that is shading and hidden surfaces. So these are the points that we are going to study in this session. What is hidden surface problem? What is Z-buffer algorithm? And what are the drawbacks of Z-buffer algorithm? Now, as we know that hidden surface problem, when viewing a picture containing non-transparent objects and surfaces, it is not possible to see those objects from view which are behind from the objects closer to eye. To get the realistic screen image, removal of these hidden surfaces is a must. The identification and removal of these surfaces is called as the hidden surface problem. We have discussed this hidden surface in the previous session also. That is, if you are holding any object in your hand and if you are looking from the front side, whatever is visible to you, that is the visible surface, and whatever you cannot see from the front side, that will be called as the hidden surface. Okay. Now we have seen the drawback of the backface removal algorithm is that it cannot detect partially hidden surfaces and it doesn't work for overlapping objects. We have seen in the previous session that this backface removal algorithm, it works on separate objects. It doesn't work if your objects are intersecting each other or they are overlapping each other. Okay. So this issue is resolved with the help of this Z-buffer algorithm. So this algorithm considers these issues of the backface removal algorithm. Now, Z-buffer algorithm is also called as depth buffer algorithm. So in question, it might be asked that explain Z-buffer algorithm, or they may ask explain depth buffer algorithm. So this is one and the same. It is one of the commonly used method for hidden surface detection. It uses an image space method. Again, we have discussed this, that to detect the visible surfaces or to identify the hidden surfaces, we have two approaches, that is object space method and the image space method. So image space methods are based on the pixel to be drawn on two dimensions. This image space method, it works at pixel level. Each and every pixel is checked over here. Okay. So the basic idea of this algorithm is what? It compares different objects based on its depth and it checks what is its intensity at each pixel level. We will see in further slides. Okay. Now consider following projection plane diagram. Okay, as I said that this is the image space method. This image space method, it deals with the projected images. Okay, so at pixel level we have to study this algorithm. So this is the diagram, and here we have given you the three surfaces, say surface S1, surface S2 and surface S3. And consider that here somewhere is the screen, and from that screen I have selected any random pixel, say XY. Now this is projected on the view plane. Here it is the view plane, say XY plane. Okay, and this is the pixel XY. I have drawn one dotted line here, and this line is crossing each of the surface S1, S2 and S3. So here is XY. Here it is intersecting this surface over here, suppose. So this is also XY point, this is also XY point, and here also one XY point is available. Okay. Here we have selected one random pixel, say XY. Now what we are going to do, we will check that pixel level depth of each surface. Now what is depth? It is a Z value, okay, which determines a particular surface is at what distance for our view plane, right? Now in this diagram, each surface has that XY value, but at different distance, that is at different Z value. Suppose now this is your view plane and here is your XY pixel, okay? Now the depth of this first surface will be from the distance from this particular pixel to here, view plane, is this distance will be the depth of this first surface, that is S1, or we can say this is the Z value of S1. Now the distance from this XY to this surface's XY value, this total distance is called as the depth or Z value of surface 2. Similarly, from this pixel up to this pixel, this total distance is called as the depth or Z value of the surface S3. Okay, so in this way we can find out the Z values, that is depths of each and every surface over here. Now, once the Z values are known, now this algorithm uses two buffers, and those buffers are called as a Z buffer and a refresh buffer. Okay, what is the task of these two buffers? So Z buffer stores the Z values of each surface. Just now we have calculated the Z values. So those Z values will be stored into the Z buffer, and refresh buffer will store the intensity values. How it will store these values, we will see with an example here. Okay, now consider the following Z buffer. This is the Z buffer diagram and this is the refresh buffer diagram. Okay, now here the horizontal line represents X value and the vertical lines represent Y value. Both the buffers are representing. This is the horizontal line and these are the X values, and these vertical lines are represented. They represent the Y values, and same for this refresh buffer. These are the X values and these are the vertical are the Y values. Okay, now suppose we have one pixel XYZ having the coordinates as say 2, 1, 2, that is X value is 2, Y value is 1 and Z value is 2. So in Z buffer, Z value 2 will be placed as shown in this diagram. Okay, so now what is the X value? It is 2 and Y value is 1. So second, we will go to the second column, and Y means Y is 1, that is this is the first row, second row, third row, and so on. So second and 1, so this cell is representing 2, 1. And what is the Z value here now? 2. That's why I am putting value 2 over here. If it is 4, 2, 1, 4, then that pixel would have been 2, 1, and this will be 4. Okay, and this is the value of Z buffer. And same I'm going to what I will store into the refresh buffer now. Refresh buffer stores the intensity values. Whatever the intensity of this particular this pixel, that intensity will be stored into this cell, that is second and 1. X value is 2, Y value is 1. So at this particular position, intensity of this pixel will be stored. Okay, have you understood what is the value stored in Z buffer and in refresh buffer? So Z buffer stores the Z values, that is the depth of surfaces, and it stores the intensity at that particular pixel. Similarly, suppose this is for surface S1, for surface S2, it will be stored here somewhere, surface S3, it will be stored here somewhere. Likewise, these buffers are updated. Now, the Z value of surfaces depends on two things. Okay, how we are going to consider the Z values? So it is important that where you are sitting and along which direction you are looking. Okay, now here we will consider the two cases, right? So in the previous diagram, consider the Z values of S1, S2, S3 as say -4, -6, -8 respectively. So I'll just show you the diagram again here. Now, suppose this is surface S1, S2 and S3, and consider this that S1, this is at depth -4, this is at depth -6 and -8. Okay, now this is your z-axis. So if I extend this z-axis, this is your 0, 0 origin. If I extend it here, I'm getting this as plus z, and these values will become now minus z. So I'm saying that it is important in this algorithm where you are sitting and you are looking along which direction. Okay, now this algorithm considers two cases, that is if you are sitting on this positive z-axis and looking at origin or in negative z direction, and similarly second case will be you are sitting at negative z and you are looking at positive z axis. Okay, these two cases we have to consider while studying this algorithm. So here we have written that consider the z values of S1, S2, S3 as -4, -6 and 8 respectively. So this algorithm can be written as, first case is what? We are sitting on positive z and looking at negative z value. Okay. Now here, what I have written, what this algorithm says, that whatever is the larger z value, that is always closer. So in previous case, larger z value, then it will be closer. Again, we will consider the previous example here. We are saying that this is at level -4, -6, and -8. So from these three, which is the larger value? Definitely it is -4. Okay. And you are, what is the first case? You are sitting over here and looking in negative z direction. So in this case, surface S1 will be closer to you. Okay. So whichever is the larger z value, that will be closer to you. So in this case, S1 will be closer to you. And whichever is the smaller value, that will be the farther from you. So in this case, that will be the S3 surface. So larger z value will be closer. So the S1 will be closer surface, and smaller z value, it will be farther. And same opposite case, we can consider that we are sitting on negative z and looking at positive z direction. So smaller z value will be definitely the closer S1 will be closer, and that will be the S1 surface, and larger z value will be the farther one, and that is in this case, in our example, it is S3. Okay. Now, algorithm starts with initialization. Okay, we know that we are going to store the values in two buffers, that is depth buffer or z buffer, and second is the refresh buffer. Okay, so initial depth we will set as this depth at particular xy level will be 0. Initially we will set the value of depth is 0, and the corresponding intensity we will set into the background intensity. So R stands for refresh buffer. Refresh value of this particular pixel xy will be the intensity of the background. And in this case, the initial depth we have to set to the maximum level. Okay, so this is infinite. Depth will be infinite initially, and refresh buffer will be same as the intensity of the background. Okay. Now, what we have to do further, that for suppose we will take now one surface or each surface one by one. Okay. So Z new means what? This is the depth of second surface or the first surface that we are taking. Okay. We will check whether this depth of this first surface is greater than this depth. Then what we are going to do? We will store this greater depth into this value. Dxy will be now Z new, and corresponding intensity of this xy will be, or new surfaces intensity will be stored into this refresh buffer. Okay, and each time we are going to take new surface, we will compare it to the previous value. If it is larger, we will replace the previous value, and corresponding intensity will also be replaced, and so on. Okay, so in this way this algorithm works, and same applies here also. If this value is less than d depth, then we will set that less value into the z buffer, and its corresponding intensity will be set into the refresh buffer. Okay, so this is how this algorithm works. We are just taking the surfaces, we are checking its depth values, and corresponding intensities will be set, and whichever is the larger value, that will be displayed. So if this problem is asked in your exam, that is explain Z buffer algorithm, so you have to clearly mention these first two things first. Okay, that where you are sitting. Okay, we have to make it clear in the very first sentence that if we are sitting on the Z, positive Z, and looking at negative Z, then these values will be there, and in opposite case. So in most of the books you will find that they have explained the case 1 external. Okay. Now we know the algorithm, but we can use this Z value to reduce the calculation. Okay. We know in the previous session also we have seen the surface equation as Ax plus By plus Cz plus D equal to 0. Now this equation can be rewritten as Z equal to, if I want to keep this Cz on the left hand side and I will keep all these other values on the right hand side, then it will become Z is equal to minus x minus by minus d divided by c. So consider this as my first equation. Okay. Now consider this a triangle, and here I have drawn some scan lines, say y minus 1 and so on. Okay. Now consider the second scan line y minus 1, and if my this first pixel is say x, okay, the next pixel to this will be x plus 1. Okay. So for x, for this particular value x, I know the z dash can be calculated as minus x minus by minus d divided by c. Okay. But for next x plus 1 value, I can find out the z value as, so what I will write one more equation. I will just replace this x by x plus 1 here. Okay. So my z dash will become now minus a, instead of x I will write x plus 1 minus by minus d divided by c. So this is my second equation. Okay. And if I calculate these two first equations, equation 1 and equation 2, I can conclude that z dash will become z minus a by c. So you have to solve this bracket, and then if you rewrite this, you will get this value here, minus x minus by minus d by c. So that will become z, and you will write minus a by c. So this z dash will become z minus a by c. So you will get this value, where minus a by c is the constant value. So next z values you can find with this simple equation. Okay, so we can in this way we can reduce the calculation part. Now, what are the drawbacks of this Z buffer algorithm? So it can only be used for opaque surfaces. Now, what is opaque surface? That is non-transparent surfaces. Okay. So we know that backface removal algorithm was dealing only with single object. Okay. If there are two overlapping objects, we have shifted to the Z buffer algorithm. Now, Z buffer algorithm is solving the problem of this overlapped objects. But now, if my overlapping objects are transparent, for example, if I hold in my hand a transparent scale, okay, transparent scale, and behind that scale, if I'm holding pen, you can see whole pen as it is, as if it is behind the scale, but still you can or you are able to see the whole pen. Okay, so because this is the transparent scale. Okay, but in this case, this algorithm fails to work properly. Okay, for transparent objects. So that's why it is used only for opaque surfaces. Okay, then what about transparent surfaces? For transparent surfaces, we have one more algorithm, that is a buffer algorithm. Okay, but in our case, or for studying, a buffer algorithm is not included in our syllabus. Just for your information, I'm telling you that for transparent surfaces, a buffer algorithm is used. Thank you. If any queries, please do ask.